Hi guys, this is lecture A27 where we're going to look at another non-parametric test called the signed rank test for matched pairs. In lecture A26 we looked at the sign test. This is now the signed rank test for matched pairs. So the outline of this lecture is very short. It will look at the Wilcoxon signed rank test, test statistic. So the signed rank test statistic is also known as the Wilcoxon signed rank test statistic. And for this test, two records are available for each item. So it's again paired data. So if patients are treated with two different methods, say method A and method B, then we have entries labeled XI for method A and YI for method B for as many patients treated. Okay, so then we note that method A has the same number of observations as method B. That's a good way to check if when data is paired. If the data is paired, then it should have the same number of observations for both methods because it's now done on the same number of patients. So the Wilcoxon rank test statistic is more powerful than the ordinary sign test, since it uses the ranks of the data as compared to the sign tests, which only uses the signs. So you remember we did for the sign test, we got the signs of the data, but now we're going to rank the signs. And the same general procedure is as follows. We have a hypothesis. We state the null hypothesis where we have the median of the differences equal to 0, or we say p is equal to a half. And remember that we have three different alternative hypotheses. We have the two-tailed, where it's not equal to, the upper one-tailed, where it's greater, the lower one-tailed, which is less than. And we specify a level of significance, alpha. But again, in this course, we will only consider the upper tail and the two-tailed hypothesis. We're going to forget the lower one-tailed test. Then we have the rejection criterion, and the rejection criterion says that if it's a two-sided hypothesis, we reject the test statistic. The absolute value of the test statistic should be greater than the critical value for us to reject, or for the one side as follows. So same as before. Okay, so then we come to the test statistic. And again, I'm going to group this test statistic into four parts. So the first part is to label the data XI and YI respectively, and then find their differences between these pairs. The order in which you label them does not matter at all. So we let WI equal to these differences between the pairs XI and YI. So we obtain then the absolute value of the WIs and then rank them in order, ignoring any WI that is 0. So the same numbers share the same ranks. And then we find something called an R plus, and that is just summing the positive ranks to give me the R plus, and then R negatives to sum the negative ranks. And then we obtain N, and it's again the same, the number of observations with the positive sign plus the number of observations with the negative sign. So N plus N negative. And then we obtain R, which is just the sum of R plus and R negative, which is going to be that N times N plus 1 over 2. So either way, it's give you the same value of R. And then we label the smaller of R plus and R negative as X. So in other words, X will be the minimum of R plus and R negative. And then we obtain a distribution of X. Now this distribution will obviously be given to you. Remember in the lecture A26 it was that NP and NPQ. Now it looks a little different. It's going to be N times N plus 1 divided by 4 as my mean, and N times N plus 1 times 2N plus 1 divided by 24 as my variance. Then we calculate our test statistic, which is now the Z test statistic, and it's going to be that X that we obtain over there minus the mu over there divided by the square root of this value over there. And we'll get our value for the test statistic. Our decision, if our test statistic, the absolute value for a two-sided test of the test statistic is greater than the critical value, we reject, and the same for the one-sided upper tail test. And our conclusion is then make our conclusion based on the decision that we've made. Okay, so let's have a look at this example. We have two red food coloring agents and are compared for retention of color in various solutions for various heat treatments with the following results. So we have 10 solutions, and each solution has an agent A and B. So you can see that this data is paired. The records are scores on a visual 10-point scale of coloring scoring. Test whether the two agents appear to differ or not at a 2% level of significance. So let's have a look at that question. This is example 1. And the first thing is to state the hypothesis. So the hypothesis is now on the difference of the medians. So we have H naught, the M diff is equal to 0 versus the alternative that the difference, the median in differences, is not equal to 0. Alpha is 2%, so 0,02, and we know that this is a two-sided test, so it's alpha over 2, which is now going to be 1%. So that's my hypothesis. The second step is then to state the rejection criterion, so we're going to reject H naught if the absolute value, because it's a two-sided test, is greater than Z alpha over 2. And if you go look at a 1% significance level, you'll get this value of 2,326 in your tables. Okay, so now we come to the test statistic, and there's 4 things that we want to do in this test statistic. So the first thing, let's label our A and B. So let B, or let A equal to Y, and let B equal to X. Okay, so we're going to label that, and we want to find WI, which is going to be XI minus YI. We want to find those differences. Okay, so I've written this out, which is now solution 1 to 10, and we want to obtain WI for each of those solutions. So let's go back to that example. So we want to find WI for the first one, so it's going to be 7 minus 4, and then 6 minus 4, 9 minus 5 to give me those W's. So those WIs will then be 3. Remember, it's X minus Y, so it's B minus A. So it's 3, 2. So now remember, the second part is then to take the absolute values of these WIs. So we're taking the absolute value, and the absolute value is just taking the positive of those values. So it's going to be 3, 2, 4, 4. So that gives me my WI. Okay, now we want to find the value of n plus and n negative. So we'll just come here on the side, value for n plus and the value for n negative. So now we want to find the value of n plus and n negative. So the values of n plus will be 1, 2, 3, 4, 5, 6, 7, because we ignore that 0 there. So we're going to forget that 0. So there's 7. And the number of negative was only 2. So we're going to have 2 over there. So n is going to be 9. Okay, so let's keep that on the side for now. Okay, then we have something we call an initial ranking. So initial rank, and you want to rank these values here in their order. So remember, we're going to ignore those ones over there, so we won't have anything there. So you want to rank these absolute values. So the first value is obviously the 1, and the second one is going to be the 2 over there. So that's the second value if we ordered them. The third one would be that 2 over there, so that's 3 there. There's another 2 over there, so that will be the fourth one. Then we move on to the 3, so we have 5, 6, and we move on to the 4, so we have 7, 8, and 9. Remember, we ignore that one over there. Okay, so this is the rank of the the absolute values of the WI, and then I want to look at the final ranking. The final ranking now is we're going to look at the ones. So we're going to look at this one over here, and that corresponds to a 1 and a 2. So this ranking for these two will be the average of these two. So both of these ranks will be 1.5 each. So this will be 1.5, and this will be 1.5. Okay, then we look at the 2s. So the 2s over there, it corresponds to a 4, and this 2 corresponds to a 3. So we're going to take 3 plus 4 divided by 2. So the average of 3 and 4 will give me 3.5. So over there, I'm going to have 3.5, and over there, I'm going to have 3.5. Okay, then we look at the 3s. So we have the 3s over there. There's a 3, so it corresponds to a 5 and a 6. So the average between 5 and 6 is 5.5. And this one is also going to be 5.5. Okay, the last one now is the 4s. So we have the 4s over there. And the average between 7, 8, and 9, because that corresponds to the 4s, is going to just be 8. So 7 plus 8 plus 9 divided by 3, because there's 3 values, is just going to be 8. So we're going to have 8 there, 8 there, and 8 over there. Okay, so that is now my final rank. Okay, so now we have the final rank, and I like to call this table, the first part. So the second part we're going to do is now calculate that R plus and R negative. So we have R plus and R negative. Now R plus is the sum of those ranks that gave a positive. So you saw we had 2 values over there that negative, so that's going to correspond to the R negative. So the rest of them will be all the positive. So these were positive. So we're going to calculate those ranks. You're going to add those ranks together. So it was 5.5 plus 3.5 plus 8 plus 5.5. Not that one there over there, because it was a negative. That one over there, which was 1.5 there. Not that 3.5, because it was a negative. And we're going to take the last one, which is 8. And if you add all these up, you're going to get 40. Now our negative is going to be the ones with the negative. So it was 1.5 plus 3.5. So we're going to have 1.5 plus 3.5, and that's going to equal to 5. Okay, then we're going to obtain something, the x. So we have that x is going to be the minimum, because it's a two-sided, so it's going to be the minimum of R plus and R negative, which is going to be the minimum of 40 and 50, and the minimum obviously is 5. So that's my second part. So we can let's label that as the second part. Okay, and this whole part here was just sort of part 1 of the test statistic. Okay, so the third thing to do then in the test statistic is now to find the distribution of x, with that small x over there. So we know that, and this formula will be given to you, and it's n times n plus 1 divided by 4 as my mean, and n plus 1 times n 2n plus 1 divided by 24. Okay, and this is proven already for the Wilcoxon sign rank test, which you don't have to know. So then we have x is normally distributed. So remember, n was 9. So we have n is 9, so it's going to be 9 times 10 divided by 4. And we're going to have 9 times 10 times 2n is 18 plus 1 is 19. So divided by 24. And this will correspond to the mu, the sigma squared. And this will correspond to the mu. So we can then say mu is equal to, if you work this out, it should give you 22, 5, and the sigma squared should give me 71, 25. So that's my mu and my sigma. So we take that, so we can call this then the third part to doing it. And then the fourth part finally is to calculate the test statistic. So the test statistic will then just be Z is equal to X. Remember, X was 5. So it's going to be 5 minus mu, which is 22, half, divided by the square root of 71, 25, and that will equal to negative 2,07. Okay, and that is then the test statistic. Remember now the fourth step is my decision in the hypothesis testing, my decision. And my decision is going to be that the absolute value of 2,07, and we had our critical value as 2,326, and that was obviously less than, so we fail to reject H naught. So we fail to reject H naught, and number 5, we can conclude that at the 2% significance level, that the two agents appear not to differ. So you need to write that sufficient evidence or insufficient evidence to fail to reject H naught. Therefore, the two agents appear not to differ. And this is in your notes as well, at 2% significance level. Okay, and that is the end of example 1. Okay, so now we're going to look at example 2 in your notes, and this example is as follows. The acidity level of 2 chemicals per unit volume are shown in this table below. Does the data present sufficient evidence to indicate that there's a difference between the acidity level in chemical A and chemical B, and test at a 10% significance level? So we're going to look at these examples, and again you can see that it's paired data. It's the same sample that has chemical A and chemical B. So if we come here, we are now doing example 2 in your notes, and we're going to look at the hypothesis as the first step. So state our hypothesis, and we know H naught M diff is equal to 0 versus H1, where M diff, the median differences, is not equal to 0, and alpha is 0,10, but we know it's a two-sided, so that makes it alpha over 2, which is now 5%. Then the second step is to set the rejection criterion. So we will reject H naught if Z, the absolute value, because it's a two-sided, is greater than Z alpha over 2, which is then 1,645 if you look this up in the table. Then we have the third step. So the third step which is the test statistic, and here we group them into 4 parts. So let's label our data. So let A equal to X in this case, and B equal to Y in this case, and we need to calculate WI, which is going to be now XI minus YI. And in the test and exam, we will specify whether what A or B is. Okay, so we have our sample, and we're going to calculate the differences WI for each of those samples. So 1 up until 10. So the first difference will be negative 0,28. So it's x minus y. So it's going to be 1,20 minus 1,49 to give me that 0,28. So I can do it for all the other samples. Okay, so now I've done all the samples, the differences, and I've then taken the absolute value of those differences. So the absolute value of this negative will just be the positive of it, and the positive ones will just remain positive, and then we can have our rank. So in the previous example, remember we had values of the same, so we had to take those averages. So we don't have an initial and a final ranking in this one because values are different. So if we rank these ones over here, you'll find that that's the first one. So number 1, number 2 will be that 0,04. The third one will be that one over there. Fourth one there. Fifth one over there. Sixth over there. 7, 8, 9, 10. Okay, so then once we have those ranks, the second thing to do in the test statistic is then to calculate that R plus and R negative. So R plus is going to be the ranks with the positive, so that's positive, 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 and positive. So I'm looking at those, the corresponding WI. So that's going to be 4 plus 1 plus 5 plus 3, and I'm going to get that as a total of 13. And R negative is then just the rest of them, so it's going to be that 9 plus 10 plus 6 plus 2 plus 8 and 7 is the last one, and that's going to give me a total sum of 42. Then remember the other part to calculate is that x. So x is going to be now the minimum of R plus and R negative. So it's going to be the minimum of 13 and 42, which is just going to be 13. So x is going to be 13. Then the third thing we do in that, once we have that x value, is find the distribution of x. So it's going to be 10 times 11. So you will get these formulas divided by 4. So it was n times n plus 1. And this one was 10 times 11 times 21 divided by 24. And that will give me a normal distribution of 27,5 and 96,25. Okay, so there we have our mu. So mu is 27,5, and sigma squared is going to be 96,25. And then the fourth thing to do is now calculate the z test statistic, which is going to be z, which is 13, which was the x. Remember we calculated x is 13, minus the mu, which is 27,5, divided by the square root of sigma squared, which was 96,25, and this gives me a value of negative 1,48. Okay, so then we come to our decision. Our decision is that we have the absolute value of negative 1,48 should be less than 1,645. So if it was greater, we will reject, but it's less than, so we fail to reject H naught. And when we fail to reject H naught, we're saying that when we fail to reject H naught, we're saying that the data present is provided insufficient evidence to indicate that there's a difference between that acidity and the acidity level of chemical A and chemical B. And so that was the last part in the last example in lecture A27. This is a question that you will find in your past paper exam pack. Question 3 in November 2013 is a good practice, so try and do it, and then hopefully next week in class we can go through it together. Thank you.